Okay, I hope you enjoyed your lunch. We're going to have a dessert of big data support services now. So I'm Mike Norman. I'm the director of the San Diego Supercomputer Center, and Ramesh Rao over here, the director of the Qualcomm Institute. He and I are co-chairing this panel on campus support for big data projects. My panelists are on the screen behind me. Ilke Altintes, who is the Deputy Support Leader for Research at San Diego Supercomputer Center. Christine Bagwell, who is the Division Director for IT Systems and Services at SDSC. And Kevin Patrick, who is in the School of Medicine. He's a professor of family and preventative medicine, and he is what I call a big data doc. Now, we're going to modify the presentation order a little bit so that it's not all SDSC and then QI. So I'm going to start with a few slides, just introducing the topic of the panel, and then we'll have Ilke Altintes, Kevin Patrick, and finish up with Christine, okay? So this is a 30-minute schedule item. We're going to together talk for no more than 20 minutes, and then we'll have 10 minutes for question and answer after the presentation. So not after the individual talks, but after all of them. And Ramesh will be moderating that Q&A. Okay, fine. So if there was one message I want to give to you today is that SDSC and Cal IT2 Qualcomm Institute are platforms for big data research and applications. And fundamentally, what we encapsulate are three things. Resources, of course, computing, storage, visualization. We heard about the big tile displays this morning. But more importantly, we house expertise and collaborative people. Our investigators love to collaborate with faculty and other campus researchers in order to make that interdisciplinary magic happen. So think of us first when you want to know, who do I collaborate with to do something in big data? And then finally, SDSC operates some for-fee data services that you'll be hearing about at the end of this panel. Okay, a few slides on SDSC. Many of you probably think that we're the Campus Research Bureau. Wrong. We are an organized research unit, and our research focus is the development and application of new tools for digitally enabled scholarship. So our research focus is the tools that you use to do your research. Okay, got that right? Now, we also operate some big systems and some services, but that is not our fundamental role on campus. So we research next generation hardware, middleware, application software, and data services. Finally, big data is our current strategic thrust, and we have a very popular bumper sticker that you can probably buy on eBay. So a few years ago, as director, I established a couple of big data centers of excellence within SDSC. So these are centers within a center, if you will. One is called the Center for Large-Scale Data Systems Research. That's directed by Chaitan Baru, who you will hear a little later on in the education panel. And its focus is the systems, the hardware and software systems that are evolving very rapidly to support the big data economy. Jim Short, who you see there, is a guy with a business background, and he's interested in the value of data. What is the corporate value of data? A second center of excellence is PACE, the Predictive Analytics Center of Excellence. This is sort of the other side of the coin from big data systems. It's how are they being used to make corporate decisions. So predictive analytics, business intelligence, machine learning, data mining, these are all within the purview of PACE, and this is led by Natasha Bollock, who will have a 10-minute talk later on today. To give you an example of what PACE does in the way of a big data application is the campus's energy microgrid, which has 100,000 sensor points that are providing streams of data that have to go somewhere to be collected and analyzed. And so one of Natasha's center's projects is to do the data mining on the behavior of our microgrid. And then my last slide is to tell you that in 2015, we'll be deploying an exciting new NSF-funded supercomputer called COMET. COMET, is an astronomical thing that has a long tail when it sweeps past the sun. COMET computer is designed for the long tail of science. This means that this will be a platform that will be easy to get on and easy to use across all scientific domains and all areas of academic scholarship. And so I think the way you should think about this is if you have some complicated big data workflow where you need a lot of storage and a lot of compute, think about running that on top of COMET in a little over a year. Okay, so that was the end of my introductory remarks. I want to then hand off to our first panelist, Ilke Altintas.
So I'm here to talk about the collaborations and research at SDSC. I work as the Deputy Coordinator for Research in addition to my own research on scientific workflows. And as most of you know, SDSC has been a data science leader for more than 2 decades, since its introduction actually in the 80s. And we have top-class researchers, highly cited researchers, and the unique part of these researchers is really an ability to build infrastructure around their research and to develop tools that are highly used and utilized by other cyber infrastructure projects. So this has been applied in essence to many large-scale data management, integration, and visualization and analysis projects, including all areas of research in the domain sciences. And as Mike mentioned, we have 2 well-established data centers, and we also have a new initiative on education of data science, in addition to the ones we had over the years. I think Chaitan will talk about that in the education panel today. So as I mentioned, SDSC researchers are principal investigators. They have their research groups, and they also have groups combined that are combinations of researchers and developers and domain experts. So this makes a nice combination for collaborations in that sense that enables infrastructure portals, it enables scientific research in different disciplines, combined with the best practices in computer science and other technological advances. So some examples I collected here has been, the GIS on the brain has been, basically we have a geospatial sciences laboratory that actually applied the geospatial techniques to brain mapping. So you see that it's already becoming really interdisciplinary when you combine different researchers like yourself together, talking in one place. And we have quite a big thrust on geosciences from enable of Mexico's Health Atlas and wildfire management and all the EarthCube related initiatives. And we have a thrust on predictive analytics, as Natasha Balakval mentioned today. And we have, I think, in all domain sciences, we have labs that combine supercomputing and data management technologies with the domain sciences. And the goal here is not to do it all by ourselves, but really to collaborate. So we have a big culture around collaborations. And I hope from this day, some other collaborations come out. So as the last slide, I want to say we have been collaborating with campus researchers and faculty, and in pretty much all the UCSD divisions and departments. So there's a list of some of the awards and proposals that were done together. In addition to our national and international collaborations, we really like to collaborate on campus because this gives us quite a breadth of interesting problems to work with. Thank you.
Okay, thanks. Kevin Patrick here from Family Preventive Medicine, and Qualcomm Institute. And we're setting up my slides momentarily. Here we go. Okay. Okay, so platforms for data-intensive research. What sorts of things do we have for opportunities for collaboration at the Qualcomm Institute? I'm going to talk about 3 of them. And our research, very important to sort of frame our research. Our research is framed around this concept of the exposed zone. Essentially, half of premature morbidity mortality is as yet unexplained and probably related to things like environmental exposures and behaviors and things like this. So that's what focuses our research. There are known and unknown, sort of hypothesized pathways for this. And the way that we have typically measured this over time is through self-report, through periodic biomarkers that are taken, or through measurement, crude measurements across the environment in which we make inferences about what happens to individuals. Things are changing, as we all know. We're all carrying devices. There are lots of new devices that we can use. So our research is really trying to leverage both person-worn technologies and newer sensors to begin to understand the exposed zone. The first project I want to highlight is the PALMS project, Personal Activity Location Measurement System. This is funded in the Gene Environment Initiative, a portfolio of projects that funded better tools and technologies that can tease out these relationships between gene environment exposures. We focused on activity devices and GPS devices, and these are GPS devices not in the phone, but devices that actually have better battery life that people could carry around for a period of time. And what this allows is the ability to characterize where people go over long periods of time to get a better understanding of what they might get exposed to in the environment. So it helps us construct a picture of a day, a week, a month, any length of time that you might imagine for a particular person's exposure. And importantly, we can allow researchers to create a study. We can allow researchers to bring whatever devices it is that they might have coupled with GPS, including additional sensor devices. They can bring the data into our PALM system and collaborate with one another in a study, and then it allows also the reuse and the analysis of those data as well. We have over 100 researchers around the world who are now using PALMS, and we're taking this in a number of exciting different directions, coupling it with GIS-related data, using it in seniors and children and whatnot, so it's been a pretty exciting project. Second project is CyCore, Cyber Infrastructure for Comparative Effectiveness Research in Cancer. This is an NCI-funded project where we're collaborating with colleagues at MD Anderson Hospital. And here, essentially, we are developing a system that allows capture of information from people in the context of clinical trials to get a better understanding, an objective understanding of patient-reported outcomes, which are now typically gathered by only self-report. We can capture these things in real time, bring them in, and share them with researchers, share them with others who are working in this area. And we leverage the home health hub that Phil Rios and others at Cal IT have been developing to capture increasingly more types of data from individuals in the context of, again, cancer comparativeness care. We hope to continue this. Our grant is being reviewed at NIH on the 10th of next month. And if so, we hope to expand use across the country. Right now, we only have users at MD Anderson, but hopefully this will scale. And then the third project I wanted to touch on is an NSF-funded project where we're looking at multi-level factors that relate to health. Here, we're taking the audacious step of essentially trying to wrap our minds around all forms of data relevant to health: genomic data, microbiomic data, medical record data, personal health data, things from Fitbits and things that people might carry themselves, environmental data, and public health related data. So imagine all of the forms of data that you might be able to bring together to begin to understand individual or population health. Providing health care and population health requires reasoning across a variety of these forms of data. We too often stay in one particular stovepipe, the medical data or the genomic data or whatever. We don't attempt to bring them together. Diabetes management, for example, or asthma care. We really need to integrate and pull all forms of data together and think about them in that way. Unfortunately, these are tough to integrate because they all sit in different silos: physical activity data and devices, social data and social network companies, weight data, genomic data, et cetera. You can imagine where these things are sitting. And so how do we think about pulling them together? So our goal here is to develop a model in San Diego that will be a platform for us to use as researchers, but also apps and services developers, to pull together all of these forms of data and create this whole health information model of an individual or a population. And we have this happy accident in San Diego of having lots of components that allow us to do this. We have Qualcomm developing their programs, or a very proactive health and human services department. We have the San Diego Beacon, which is the electronic medical record exchange in the community. We have one of the few communities where, in fact, this works. And San Diego Association of Governments, which has very rich GIS data sources. And so our challenges in this are new data types, dynamic environments, and doing this, modeling it in a particular environment where we can capture all of these forms of data. So we're working on building on an architecture which will bring these in to this Delphi model. We are opening this architecture up to a variety of entities that might be interested in using it, from app developers to clinical environments to public health and population health folks. And we're working with data scientists, Dr. Baru, Dr. Papakonstantinou, and others, to help us think through how we develop a model that will allow us to interface. We're talking about visualization approaches and creating essentially this ecosystem that allows us to bring analytics to all of these forms of data in one particular geographic area, which is, again, very important if we believe that health is place. And we know for a fact that much of one's health is, in fact, associated with that. So this is going to be I think, a very unique research platform that, with luck, will be successful and allow us to do some pretty innovative work. Happy to chat more about this with folks as we go along. So that's it. And talking about potential applications that can be developed on top of this as well. All right, thanks.
Hi, I'm Christine Bagwell. I'm here from the San Diego Supercomputer Center, and I'd like to talk to you about SDSC Cloud. So you heard a little bit about the Supercomputer Center already. As our name belies, we're known for HPC. We have a brand new grant in concert with Cali T2. We're bringing some high-speed networking to campus, and you might have been hearing about a new MAS program that will be coming out next year, put on with Computer Science Department, Data Sciences, and Engineering. Along with that, we also are a leader in cloud-based computing, particularly the open source-based OpenStack. SDSC Cloud is currently 2.5 petabytes raw. We have 2 clusters, one here at the Supercomputer Center and one in Oakland at Office of the President for DR. But aside from talking to you about compute and storage, I want to talk to you about what SDSC Cloud is retooling in Cloud V2 to do. And it's about a lot of the principles that you've heard about today. Being able to find your data, ensuring that there's a workflow that makes you tag it, at least in a minimal sort of way, so that you or that those in your lab can find the data later. Having a place that can scale with your data stores so that you're not having to worry that your computing person has provisioned it correctly, that you can put up as much as you need based on bursts in your own workflow. Know that it is next to large data stores, so you're not having to think about these things that right now probably take a lot of your time, especially if you're working with big data. Being able to throw up web servers or compute servers as needed and take them down so that you're not provisioning whole racks of servers, and making the best use of your resources. And then also being able to get to that nirvana of sharing data with each other or publishing it along with your proceedings. So what we've built is a research platform for large-scale data. And the reason is that we're watching what's going on in industry and elsewhere with research computing. And we're seeing that the architectures are generally cloud-based when you get to this scale of data. That's what Netflix has touted with their way of doing database architectures. I was entertained to find there's another DAAS, not data as a service, but decisions as a service, that is largely cloud-based. And of course, Rackspace's own big data platform is Hadoop on the cloud. The reason that we are using an open source platform is not just because we need to roll it ourselves, but it's so that we can innovate on the back end for our research use cases, the things that all of you are doing, the things that we're doing at the Supercomputer Center. So what is data as a service? Well, this is a notational diagram to really show you that there are layers, and that we roll a bunch of different services that we have packaged together rather than just saying, here's some storage, make use of it. So first step in this is to partner with Globus Online, that I think was cited in a couple earlier talks this morning, that's largely been known in years past for grid FTP, but is also really becoming a great way to do web-based transport of large data stores. So we already have endpoints established for all of our national systems, and we're working to establish a front end for our storage system so that you can move things around between these different places. Chaitan Baru, who's here today, he and Vishnu, who's also here today, have a pilot called Shared Data Space that does this data as a service on top of SDSC Cloud and basically gives you a place to throw your stuff up. It ensures that you tag it appropriately and that it allows you to move things around between different resources and then share it out with people in and around the system, as well as any collaborators around the world. So I think I mentioned this a little bit, but we also heard this in earlier talks, that you do need to think about your architecture at the outset. Part of this is because of speed, working with different collaborators, but it can also really rack up charges. Especially if you're doing something that's very chatty, you can incur a lot of additional charges using Amazon Web Services. Another thing that you get with SDSC is that we can expose some of the logs to you. We can tell you what is happening with your program. Do you need to package your transport into smaller chunks, for example? Now, I want to show you a couple different examples that we're doing with our data as a service specializations. There we go. This one is BioKepler, and this is an object-oriented way of making use of storage and compute sources. So you can actually program in your own scientific workflow. And this is running on our beta OpenStack Nova instance. This is, I know, super, super tiny. This is the Neurosciences Information Framework. One of the PIs is, or co-PIs is here, Amarnath Gupta. And what it does is it takes many different data sets that would normally be apples and oranges and gives you a way to search across them by building ontologies. And so what we would like to do on our data as a service platform is say that you're in economics or say you're in IRPS, something completely separate, be able to build your own ontologies across all of your different data sets. And you heard a little bit about PACE. We would like you to be able to take one of our data mining workshops and order up our starter kit, maybe with a specialization for retail or for energy. So with that, I'll open it up to the panel discussion.
Stay up there.
Okay.
We're a panel.
Okay.
So we have time for questions. We have mics that we would like to pass out before you pose your questions. We have about 5 minutes or so for questions from the audience. While you're gathering your thoughts, let me ask the obvious question of Kevin. Do you address issues of privacy, especially since you're working with health data?
Yes. Yeah, we do much more so in the specifically in the SciCore project, where again HIPAA compliant issues. But we're planning to build out Delphi in ways that allow HIPAA, FSMA, all the new compliance things. So we're working with Lucilla and Machado and Claudio on that. Huge issue. But I will say we are also exploring orthogonally the fact that privacy is in a lot of these new data forms is not a monolithic concept. We're finding in our health data exploration project with the Robert Wood Johnson Foundation that people feel differently about this as far as how we might actually think about handling different forms of health data.
I noticed you had Facebook on your slide.
That's
so
right.
They certainly don't care for privacy.
And if people volunteer their information, then we're more than happy to have them have it.
Christine, do you provide services that honors HIPAA requirements?
SDSC does. We have a cloud called Sherlock Cloud, which is provides kind of the whole end-to-end solution if you have HIPAA or FSMA needs. That's not my area, but in our center.
Did you want to add to that, Mike? No?
Sherlock.
Sherlock is the answer.
Solved.
We have a question from
Sherlock.com. Check it out.
Yes, I do. I just wanted to ask Kevin. So, the information sources that you listed, are you expecting them to give the data to you, or is this going to be independent from a lot of whether it's the Fitbits or the Facebooks?
Very good question, and we would hope that people would, that these data would be accessible in sort of uniform ways, but they're not. My dream here in San Diego is to create probably a donate your data initiative for some of the personal related data. Many people we know are willing to do this. We are connecting with the San Diego Beacon Project with respect to the medical related data. So we'll be developing data use agreements with them and use anonymized data that might come from other existing studies that are happening. But again, the best path, I think, for this particular project is to get enough people who are willing to donate a variety of data for us to begin to experiment with the person-level data. Many of the geographically characterized data and other public health data we can access and integrate anyway.
Thank you.
Amarnath, I heard you threatening to ask some tough questions. We have a question back there?
Hi. Sorry, I want to know if your service include chip design, because now I have an idea about bacterial biomarker for food safety, and if I identify biomarker, and I would like to commercialize the chip to identify the bacteria strain, and I don't know if you have such technique skill to to do the chip design and the device design and then commercialize.
I think that's a question for Rajesh Gupta. Rajesh, are you here? There he is. Do you make chips?
Lab on a chip.
Lab on a chip.
Lab on a chip initiatives that might help generate data from biomarkers and things of that sort. Are there initiatives?
If there was an online thinking, this is it. So, you know, I go back to our faculty who are at the intersection with biology and medicine. We have a program with them, bioinformatics program and systems biology program. And I asked them, just as an institutional bean counter, what can we do in terms of building laboratory infrastructure? Can I buy a mass spectrometer? Should I do this or should I do that? To create more and more data. Because I often feel that if you're the data source, you are the first one to infer from that data source. And what I understand, that there are opportunities that are much more on the back end of how the data is generated. This may not be answering the question, by the way, but I wanted to get it out anyway.
Spoken like a good administrator.
But I also understand that when it comes to data, lab on chip or data that we're new assaying and new technologies that are coming out, that are moving so rapidly in the commercial market space that actually our ability to process and our unique strengths to process is a lot more important than being able to generate that data internally. So I am in a conflict myself. I would love to see some infrastructure here in which we are the data source, but also, you know, the faculty who work in that space have been looking for ability to sort of build the ability to process that data.
So we have time for one more question, but let me add that there are some researchers, faculty here who are not in the room. Joe Wang in nanoengineering, Hua Lo in ECE have been working on this lab on chip designs. So. A question to the left.
Yeah, this is Jonathan Watanabe, School of Pharmacy. So in terms of, I think this is for Kevin, is that going to be built towards something like eventually real-time decision support?
Yes, with luck. And I think we're teeing up a little bit what Adil might talk about 911 data, but that's actually a great interest of the folks at the San Diego Health Beacon, essentially the Health Information Exchange. And so we're talking with them about this coupling and bringing more proximate to any particular event that would be necessary, these forms of data. A lot of work to be involved in that, but that's a vision.
So we are at the end of this session. Thank you very much for being on this panel.
Okay, I hope you enjoyed your lunch. We're going to have a dessert of big data support services now. So I'm Mike Norman. I'm the director of the San Diego Supercomputer Center, and Ramesh Rao over here, the director of the Qualcomm Institute. He and I are co-chairing this panel on campus support for big data projects. My panelists are on the screen behind me. Ilke Altintes, who is the Deputy Support Leader for Research at San Diego Supercomputer Center. Christine Bagwell, who is the Division Director for IT Systems and Services at SDSC. And Kevin Patrick, who is to give to you today, is that SDSC and Cal IT2 Qualcomm Institute are platforms for big data research and applications. And fundamentally, what we encapsulate are three things. Resources, of course, computing, storage, visualization. We heard about the big tile displays this morning. But more importantly, we house expertise and collaborative people. Our investigators love to collaborate with faculty and other campus researchers in order to make that interdisciplinary magic happen. So think of us first when you want to know, who do I collaborate with to do something in big data? And then finally, SDSC operates some for-fee data services that you'll be hearing about at the end of this panel. Okay, a few slides on SDSC. Many of you probably think that we're the Campus Research Bureau. Wrong. We are an organized research unit, and our research focus is the development and application of new tools for digitally enabled scholarship. So our research focus is the tools that you use to do your research. Okay, got that right? Now, we also operate some big systems and some services, but that is not our fundamental role on campus. So we research next generation hardware, middleware, application software, and data services. Finally, big data is our current strategic thrust, and we have a very popular bumper sticker that you can probably buy on eBay. So a few years ago, as director, I established a couple of big data centers of excellence within SDSC. So these are centers within a center, if you will. One is called the Center for Large-Scale Data Systems Research. That's directed by Chaitan Baru, who you will hear a little later on in the education panel. And its focus is the systems, the hardware and software systems that are evolving very rapidly to support the big data economy. Jim Short, who you see there, is a guy with a business background, and he's interested in the value of data. What is the corporate value of data? A second center of excellence is PACE, the Predictive Analytics Center of Excellence. This is sort of the School of Medicine. He's a professor of family and preventative medicine, and he is what I call a big data doc. Now, we're going to modify the presentation order a little bit so that it's not all SDSC and then QI. So I'm going to start with a few slides, just introducing the topic of the panel, and then we'll have Ilke Altintes, Kevin Patrick, and finish up with Christine, okay? So this is a 30-minute schedule item. We're going to together talk for no more than 20 minutes, and then we'll have 10 minutes for question and answer after the presentation. So not after the individual talks, but after all of them. And Ramesh will be moderating that Q&A. Okay, fine. So if there was one message I want